Okay, last section in the chapter is exponential equations. So we're going to start solving equations where the exponents have the variables. So up till now, you had a question that looked like this, something like 2x to the 3/4 equals 16. And you knew to divide by 2, x equals 8. And notice where the variable is. It's in the base. And we learned yesterday that to get rid of this, we simply raise to the reciprocal. So we'd raise this to the 4/3 power. The cube root of 8 is 2, and 2 to the 4th is 16. But today we're going to be a little different, and as you're going to see, our bases are going to be known, but our exponents are going to be unknown. So we have to handle that a little different way. So the first thing that you have to realize is in order to solve equations with exponents, the bases have to be equal. So here my base is 3, and here my base is 3. So I'm a happy camper when the bases are equal. Because I already have the bases equal to each other, I can now ignore them and just work on getting the exponents equal to each other. Solving this gets me a simple 2x equals x plus 3, so x equals 3. And if we went back and did a quick check, 3 to the 2, now we think x is 3. Does that get me the same as 3? Yep, this is 3 to the 5th, and this is 3 to the 5th. So it worked. All right, so of course you may be asking, well, what happens when the bases aren't the same? Well, we must get the bases the same. So we have to rewrite this. So let's give it a little notes here. Rewrite so that the bases are the same. What am I going to do? All right, so here is my base of 49, and that definitely is not the same as 7. However, though, you may think, wow, 49 can be rewritten as 7 squared. And I got a 7 over here. So now I have like bases. So all I did was take that 49 and rewrite it as 7 squared. I'll bring down the rest, and now I'm back to before. I notice that my bases are the same, so I can ignore them. And now I'll just solve the exponents. And look at that, x equals 1. Now some of you may have been able to figure that out without even having to do all this change of base formula stuff. You might have been looked up here and said, well, 49 is 7 squared, so this has to be 1. Great. Again, this one could be really obvious. 5 to what power gets me 1/5? Well, most of you right away might say, oh, -1. If I rewrote this so that the bases are the same, I've got two choices here. I can rewrite this in base 5 or base 1/5. And most of you are familiar with base 5. So on my last page here, I gave you a little chart with all the bases that are most common in the homework. So if I look over here and I notice that 5 to the first power is 5, and I look down here and I find 1/5, I can rewrite 1/5 as 5 to the -1. And then I can ignore my bases, and voila, x is -1. All right, here we go. 1/2 and 8. We've got to write them in like bases. So I'm going to come to my last page, and I'm going to look for 1/2, and I'm going to look for 8. Over here is 1/2. And over here is 8. Oh, so the common base is 2. Alright, so I'm going to come over here, and this 1/2 I'm going to rewrite as 2 to the negative 1. And I still have my x. And this 8 I'm going to rewrite as 2 to the 3rd. So I haven't changed anything. This is 8. This is still 8. And then I have 2 minus x. Alright, so I can ignore my bases now because they're the same. Over here I'm left with negative x. But careful, over here, remember, a power raised to a power means I have to multiply. So I'm really left with 6 minus 3x. Solve away. X equals 3. And I can check myself. Does 1/2 to the 3rd power get me the same answer as 8 to the 2 minus 3? Well, 1/2 to the 3rd power is 1/8. 8 to the negative 1. Oh, that's right. When you raise something to a negative exponent, you simply flip. So 1/8 does indeed equal 1/8. Right. This is your lovely chart, which will help you immensely in the homework. If you know it, that's great. If not, write it down. See you tomorrow.